Now I'd like to briefly discuss priming memory. Sometimes we can see something and a little later what we saw influences our behavior even though we don't recall what we saw. And sometimes even at the time we weren't aware of what we were seeing. And the example I mentioned earlier in the course was if in a movie the slogan "Drink Coca-Cola" is flashed on the screen a very short time, too short for most people to recognize it, then if someone is already thirsty, there could be a very slightly increased chance that shortly afterwards they'll buy Coke rather than some alternative. So there's a kind of memory happening, but the visual information can't be expressed verbally, and typically the effect doesn't last very long, perhaps only a matter of minutes. This type of memory is called priming, because the brain is primed by sensory inputs in a way that favors certain later behaviors. And the clearest example of this phenomenon in the lab is perhaps what's called tachyscopic image recognition, that again I described earlier in the course. The image of some object is seen very briefly, less than 1/10 of a second, and is followed by another image that blots out any retinal afterimages and makes quite sure that the visual information from the object was only available to the brain for a short time. Other images are shown, each followed by a mask, and the subjects are asked to identify each object, but typically only get about 10% right. But if exactly the same object is presented a second time, a little later in the series, also followed by masking like this, then subjects are about 3 times as likely to identify it correctly than the first time it was presented. So how can we understand what's happening here? Well, let's suppose that this represents the columns in a cortical area that has some capability to discriminate between different types of visual objects. If an image of a pair of scissors were seen under normal circumstances, a set of columns like this would detect their receptive fields. Each of these activated columns would have some recommendation strength in favor of saying scissors, and that would be the predominant speech recommendation across the set. If the period in which the visual information available is very short, but the visual image presented to the eyes is exactly the same, then it'll tend to be the same columns getting input, but most of them won't get enough input to detect their receptive fields. The ones that do detect their receptive field, if any, or perhaps just a few, will tend to be some random subset of the complete group. Most of the time, that subset won't have enough total recommendation strength in favor of saying scissors for the behavior to be accepted. Now, suppose a little later the same image is briefly presented. Again, some small random subset will detect their receptive fields. And again, usually there won't be enough total recommendation strength to identify the scissors. But occasionally there could be one or more columns that by chance are activated on both occasions. If columns have recommendation strengths in favor of indirect activation of other columns that were recently active at the same time, this could lead to indirect activation of the other columns in the earlier brief presentation. This enhanced set of columns is a somewhat larger subset of the set that will be activated in response to a normal perception of the image, and it's a bit more likely to have enough total recommendation strength to identify the scissors, to speak the name scissors. So we have an understanding at the column level, and the description has used information mechanisms much the same as for other phenomena we discussed earlier. So we know how to map to more detailed levels if we wanted. For example, as I discussed in working memory, there have to be receptive fields that record the recent correlations in activity. Indirect activation strength on the basis of just one recent episode of simultaneous activity has a reasonable probability of being useful over a short time, but unless repeated, it becomes less and less likely to be useful over time. So the recommendation strengths will decay to 0 unless there's some repetition. In terms of natural selection, in real scenes, we may just get a glimpse of, say, a snake in the grass, and as it moves, we may get different glimpses. Having an indirect activation capability of this type on this timescale could make it possible to put together the different glimpses into perception of the object. As we've discussed before, indirect activation needs receptive fields that can support the activations. But in this case, they need to last for just the order of minutes. And if you recall, there's a form of synaptic weight change that lasts for that sort of time. There's a form of LTP that lasts for minutes, another form that lasts for the order of an hour, and another that lasts more or less indefinitely. So there have to be cortical areas that create these types of receptive fields on these kind of timescales. In other words, using the short-term synaptic weights to define the receptive fields. So that concludes our discussion of priming, and in the next section I want to step back and have a look at the different ways in which information can be indirectly activated in the brain.